Hey everyone, and welcome to This Explainer. Today, we are going to completely demystify the absolute magic behind modern software development. We're talking about building CI/CD pipelines, and right at the center of it all is our unlikely hero, an automation tool known as Jenkins. I mean, if you've ever wondered how tech giants are pushing updates to your phone multiple times a day without breaking literally everything, well, you're in exactly the right place.
Okay, let's dive into this. Before we get bogged down in the heavy technical architecture, I've got a quick question for you. Think about the name of this highly sophisticated, modern DevOps server, Jenkins. Where does that name actually come from? Because let's be honest, it doesn't exactly sound like some cutting-edge Silicon Valley acronym, does it?
The history here is actually fascinating. So, Jenkins derives from a 12th century term, Little Johns. This was historically used to describe the Cornish and later on the Welsh people. It was most likely a way of classing them as the illegitimate offspring of the highly unpopular King John of England, who used to be the Earl of Cornwall. So yeah, our modern software hero is actually named after a medieval royal scandal. Just a really fun piece of trivia to keep in your back pocket.
Section 1. Demystifying the CI/CD pipeline. Let's see exactly how we solve those notoriously slow manual software deployment processes of the past.
And here is the face of that automation. Meet Jenkins. Visually represented as a helpful butler, and honestly, Jenkins is exactly that for your development team. It's an open-source server that basically serves up automated builds and efficiently manages your entire software lifecycle house. It takes over all those repetitive, manual tasks so your developers can just focus on what they do best, writing great code.
Now, to truly understand our butler's workflow, we really need to look at the two halves of the pipeline. First up is the CI phase, or continuous integration, where code changes are integrated and tested instantly to catch bugs right away. Then the CD phase, continuous delivery, takes over. This automates the delivery and deployment of that tested code straight to production, creating a completely seamless assembly line.
And this brilliantly illustrates how that assembly line works in practice. It triggers the absolute second a developer commits code to a repository like Git. Jenkins instantly grabs that new code, builds it, and runs automated testing. If everything passes, Jenkins pushes the final package to a production service, like AWS Elastic Beanstalk, for example, which handles all the infrastructure and scaling. It's a completely hands-off chain reaction.
Section 2. Inside the Jenkins architecture. How does our hero actually operate under the hood?
Before we look at the actual wiring, it's definitely worth noting why Jenkins became the absolute industry standard in the first place. And the secret sauce? It's extensive plugin support. Seriously, whatever you need to do, there is likely a plugin for it. Combine that with a massive, highly active open source community, platform independence, and the ability to scale up by adding distributed build nodes, and you have a tool that integrates with virtually any workflow on the planet.
Structurally, Jenkins is a Java-based application. It utilizes something called the Stapler Web Framework to tie its internal models to the web UI that you actually interact with. By default, it communicates over port 8080, though, that's super easily configurable, and it fully supports TLS security for HTTPS connections. But crucially, its architecture relies on distributed build agents. That means the main Jenkins server can delegate the really heavy testing and building tasks across multiple different machines and operating systems.
Section 3. Building your first pipeline. Let's move from abstract concepts to tangible application.
We can boil the whole process down to 4 overarching phases: installation, configuration, definition, and execution. And honestly, getting started is surprisingly easy. You don't need some massive complex server setup to begin. You can actually install Jenkins using a single Docker run command right on your local machine. You just map port 8080 to pull the latest long-term support image, and you're off to the races.
Once it's installed, you'll be greeted by the Manage Jenkins screen. Configuring the server is literally as simple as adding the essential tools your specific project needs. For most modern workflows, you'll absolutely want to make sure the Git and pipeline plugins are installed right from the get-go.
Next, we have to guide Jenkins on what we actually want to build. From the dashboard, you just select New Item, choose the pipeline option from the list, and give your project a recognizable name. In our case, let's keep it simple and just call it Test Pipeline.
Now, what's really interesting here is the pipeline definition section, because this is where the magic happens. You write your pipeline logic using groovy syntax, and you can leverage either declarative or scripted formats. In this basic Hello World script, we're instructing Jenkins to use any available agent, and we outline a single stage that literally just echoes our text.
With our script saved, we click Build Now. This manually triggers our whole CI/CD flow. Jenkins reads the Groovy script,
executes the code, and then dynamically displays the results directly in the dashboard's stage view. You can see right there that our hello stage completed successfully, and it even tracks the average execution time. In this case, a lightning-fast 60 milliseconds. Of course, a real-world pipeline does a whole lot more than just say hello, but scaling it up is practically effortless. Here, we've expanded our simple script to include 3 distinct stages. You can easily mimic a complex deployment process. Say, stage 1 is building, stage 2 is regression testing, and stage 3 is deployment. We've even tossed a 10-second sleep command into the first stage just to simulate a longer, more realistic build process.
As pipelines get more complex, visual tracking becomes absolutely crucial. And this is exactly where the Pipeline Timeline plugin shines. It's just a fantastic way to visually track build events and their durations. You can see exactly how long stage 1 took compared to the others, making it incredibly easy to identify any bottlenecks in your deployment testing process. And just like that, you have successfully implemented and visualized a Jenkins pipeline.
Section 4. Visualizing and Cloud Alternatives. The technology landscape is always evolving, so let's look ahead at how CI/CD automation adapts to modern, fully cloud-hosted environments.
Just compare our traditional Jenkins setup with a cloud-native approach like Azure DevOps. The underlying principles of CI and CD, they remain exactly the same, but the tool set shifts. Here, code changes committed to Azure repos feed directly into Azure pipelines. The pipeline handles the continuous integration, utilizing Azure test plans, and then continuously deploys the resulting artifacts into Azure Artifacts, and finally, out to production environments. It's an entirely ecosystem-contained alternative to hosting your own Jenkins server.
So the really crucial point to take away from all of this is that whether you choose the massive plugin ecosystem of Jenkins or a fully integrated cloud platform like Azure, the era of manual deployments is well and truly over. Automation isn't just a luxury anymore, it is an absolute necessity. Which leaves me with one final question for you. Armed with this new understanding of CI/CD pipelines, what is the very first step you will take to automate your own development workflows today? Think about that, apply what you've learned here, and go build something incredible.